Good afternoon, everybody, and thank you for joining us. My name is Cheryl Jonathan DeProza, and Gino Sigismondi and I are joined today by special guest Dr. Michael Santucci, who is president of Sensaphonics Hearing Wellness, and he's going to talk us through today your hearing, why you lose it, and how to protect it. But before we get into that, just a few items of housekeeping. This webinar is being recorded, and you can always go to shure.com/training to view all of our webinar archives. This one should be available sometime, hopefully early next week. But if you visit shure.com/training, there's a ton of great information there across a wide variety of topics. So feel free to spend some time perusing all the great training we have, shure.com/training. And then second of all, at the end of the webinar today, we will get to questions. So please feel free to type any questions you have into the question pane. If you don't see it, look for a little toolbar on the upper right-hand side of your screen with a little orange box and a white arrow. Click on that. That will maximize the pane. And type in any questions you have. As I said, we will get to as many of those at the end of the session. So that wraps up the housekeeping. Let's take it away. Gino, get us started.
All right, thanks, Cheryl, and thanks to everyone for joining this afternoon. Talk about a very important topic and popular topic based on the number of people that are logging into the webinar. So it's great to see. It's a little different than type of webinar than we usually do, where we're talking very much about gear and how to use gear and all that sort of stuff. But today we're going to talk about your health, really, your hearing health. And we expect that most people that are on this webinar, it's probably something they care a lot about. And we have the expert authority here with Dr. Michael Santucci to help guide us through this. So I thought a good place for us to start might be to turn it over to Michael and tell us a little bit about his company and what they do.
Thanks a lot, Gino. Before I start, I'd like to thank Shure and Gino here for inviting me to speak on this important topic and to reach as many people as we can. Shure has been very supportive of the hearing loss prevention effort, and I'm very happy to be here. Thank you. Sensaphonics Hearing Wellness is a multifaceted company. I am an audiologist, a doctor of audiology, and pretty much everything we do is based on the principles of audiology. But in our company, we have a number of different functions. One of them is a lab where we actually build our own products. We also do a lot of research and development of products, and we run research projects in the music industry in conjunction with audiology principles. We work with other industries outside the music industry, like racing. There's Danica Patrick with one of our earpieces in, and we've been on every space shuttle program and every space station program since 1999 with NASA. But let's get back to music here. And one of the things, having done this for so long, is that I couldn't understand why it is that people in the music industry aren't protecting their hearing. It seems to be just a no-brainer. And in fact, I had somebody that takes photographs in the music industry who was a little bit naive about this and said, boy, you must be so busy. Everybody must be coming in all the time to get their hearing checked. And I go, no, they don't. And he goes, really? Because I get my vision checked every 6 months, because if it's a little blurry, I don't have a good picture. But it doesn't go that way. So what are the reasons? Well, the number one reason I feel, from what I've seen with the musicians, I've probably seen about 30,000 musicians over the 27 years I've been doing this, perception that there's going to be too much compromise to music. Let's face it, performance is about being able to hear yourself and perform, because you've got all these people looking at you. And if I give you something that's going to negatively affect the way you perform, then you're probably not going to want to use it. So there's a perception that there are no good tools out there that you can still hear your music clearly, and so that's one of the reasons. There's also a lack of awareness that there are tools. Well, where do you get them? People may know about custom earplugs or in-ear monitors or seeing an audiologist, but it's not always something that they're aware of where or how to get them. There's a misconception that anything to protect your hearing is going to be out of your budget. One of the things I do say to people is, what's the price tag you're going to put on your hearing? If you save $100, well, at least you'll be glad you saved $100 after you've injured your hearing. I don't see that as being something. So, yes, things can get expensive, but there's always something affordable for you. that works well. It's inconvenient to see a doctor of audiology. Our business hours typically go 9 to 5. Your business hours go 10 a.m. to 4 a.m. here in Chicago, or 9 p.m. to 4 p.m. 4 a.m. So it's not always the first thing you want to do is get off the road from a tour and run in to see the audiologist. So many times audiologists are now getting out to shows and trying to bring the message to the artist, but that is a big problem. Some believe that they've already ruined their hearing enough that it's too late for them, but again, I always assimilate that to cutting your finger off halfway and then continue to saw it. You know, you might as well just stop and see if you can salvage what's left to use what you have of your finger. So it's never too late, being the point. It won't happen to me. That's another one. We're not too loud. Everybody says, no, yeah, but we don't play too loud, and my ears don't ring. I'm fine. And I ask them, how loud are you playing? And nobody really knows that answer. So
just not too loud. Right?
Just not too loud, right. And then, of course, there is a small percentage that don't care. But when I started in 1985, I would say that was the larger percentage that people would say that, and I think it was based on no awareness. I just don't care about my hearing. But you don't hear that much anymore because of the efforts that have been made.
Seems like there's been a lot more emphasis on the awareness aspect of it recently.
Yeah, very much so.
Starting with a lot of more famous musicians, the legendary ones that are now coming out publicly and saying, yes, I have this problem now because of all the years of...
Yes, and then there's organizations. World Health Organization has come up with an initiative predicting that 1.5 billion young people are going to lose hearing in the next 15 years because of concerts, clubs, and personal listening devices. Music Cares has stepped up from the Grammy Foundation to help give away earplugs backstage at shows. The AES, Audio Engineering Society, has a technical committee on hearing and hearing loss prevention, and it has now 2 seminars, 2 conferences based on this. And so NAMSHO, National Hearing Conservation Association, Audiology Association, they're all coming around to talk about this, and it seems to all finally be coming to the forefront where we're going to get enough education. That's what we hope, at least. In our clinic at Sensaphonics, we have the ability to do all the testing there, and I think that kind of separates us from other companies because we are audiologists. So yes, we do the manufacturing and the product design and sales and all that stuff, but we also have the musicians clinic. So we do have some specialized testing that tests hearing up to 18,000 hertz, which is rare. We do a lot of lifestyle profiling, consulting. We realize the need for privacy. We work with Rock and Roll Hall of Fame artists as well as probably about 2,000 local musicians. And by the way, we treat all ears equally. I don't believe a big rock star who's in the Rock and Roll Hall of Fame's hearing's any more valuable than the person that's in a garage band trying to get started. You pay the same price at Sensaphonics and you get treated the same way, but everybody's privacy is important. We promote hearing loss prevention strategies with the population, the music population that is purely volunteer. So I tip my hat to the music industry because it is really the first industry that is taking hearing loss prevention as a voluntary effort without being required. Where in industry, you're working with a factory or in the military or in coal mining, you're required to wear hearing protection. You could lose your job. You're forced to be safe. Musicians are leading the way to say it's important and I'm doing it on my own even though I'm not forced. So I think it's wonderful.
Something I wanted to mention actually, because you're talking very specifically about the services that you offer at your clinic, but since not everybody may have the ability to come to Chicago or to bring you where they're at, don't correct me if I'm wrong, but don't you have a network of audiologists that you guys have sort of...
I should mention, audiology as a group, we are not educated on... We are on hearing loss prevention strategies, but not so much specific to music. And in fact, most audiologists would, like the general population, wouldn't realize at a big show that there's a monitor engineer and a front of house engineer. They think the guy out front's mixing everything. And so we run seminars 2 days for audiologists to learn about the music industry, the problems in the music industry, and things we do to help. They're called Gold Circle Audiologists. And if you were to go to the Sensaphonics website, we have over 100 audiologists in different cities that are now qualified to speak to you with some degree of education and knowledge of your problems. So feel free to go to the website, Gold Circle, find an audiologist, it'll say.
Great.
So when you go to see somebody, and hopefully these Gold Circle people will follow this protocol, but every hearing loss prevention program has certain components to be successful, and they are a case history. We want to know what's going on in your life, both with loud sound from your career and also in your medical history. Educating and motivating you to use the things is very important as well, because without that, in fact, all research and hearing loss prevention programs show that unless you educate and motivate the worker or the user of hearing protection, that they probably won't use it. In industry, engineering and administrative controls are big. If I have a punch press machine that causes you to have to wear hearing protection and get your hearing checked, if I can make the punch press machine quiet, then we can get rid of that, and that is always the optimal way to go. Unfortunately, for music industry, that's only possible in schools of music where they have a controlled environment that doesn't change, and they can talk to the administrative control, being teaching the instructors not to play it fortissimo for 2 hours, and having some curtains or maybe some separation and time off and things like that. In the real world, those aren't very practical. As I said earlier in the last one, you're not going to the bar mitzvah and telling them where you're going to set up for the best acoustic performance for your hearing. You're going to go wherever they decide to stick you. So that doesn't work too well. The next component, audiometric monitoring or hearing testing, is the cornerstone of every hearing loss prevention program. Without it, you really don't know if you have damage or if we're controlling the injury. So sound level measurements, the next one. Are you even in need of protection? And there was a lot of issues saying that maybe not all musicians need it. But actually, we've even found in symphony orchestras that the F-hole in a violin can reach over 115 dB right at your head. And that at a study we ran in the Chicago Symphony Orchestra back in the 90s, 70% of the violinists had a noise notch in their left ear from their own instrument. So
Not
sound
just
levels,
those heavy metal guitar players.
No, it's all instruments, and so sound levels would be nice to get if you can. Always done an A weighting, and of course then there's molding and fitting of a protective device, which seems to be where everybody likes to skip to and not use any of the other ones. But remember, that may work in a musician type of protocol of the gear is going to fix it, but without those other things, you really don't know. And with all this information, we can do detective work on each individual. We treat you differently than the guy in your own band or another bass player or another guitar player. Everybody's an individual.
We thought we'd take just a quick look here for those of you who may not have much sense of what's actually going on with the hearing system of the human body. So we'll not get too deep into it because we could probably take up more than an entire webinar just on that topic, but maybe you could give us a little bit of the important bits that someone would need to know.
Sure.
About.
So we'll cover some of the important areas, but if you do want more information, let me just say that there is a wonderful video on YouTube called Auditory Transduction, if you can write that down, by a gentleman named Brandon Pletch. It is really an accurate and fascinating animation of how music goes from the ear to the brain in each part and how they function. So if you're actually interested in that, that'd be the best way to learn as fast as you can and see it in a very interesting manner. What I'm showing you here are the basic parts of the hearing mechanism. There's an outer ear portion, a middle ear portion, and an inner ear portion, and the fourth portion that isn't shown here is the brain, because that's what you hear with. The ear only gets the information up there, so if I cut that auditory nerve, you're deaf, even if your ear is perfect. So remember, perception is all in the brain. But what was this system designed for in human beings, if you believe in evolution and early human beings? It's actually your sense of survival. You might say it's your vision, but if that was the case, animals would wait for you to walk by and just kill you from behind, or wait for you to go to sleep and kill you while you were sleeping. But your ears kept you alive by being able to be great amplifiers that could hear very soft sounds from long distances. And so it's a fantastic amplifier that's built that way. And then fortunately, humans started adding volume, and now we put in loud music on top of a great amplifier, and what happens is the nerve cells on the inner ear get damaged. But let's start at the outer side. That thing on the side of your head called a pinna or ear has very little to do with amplifying sound. It does help you collect sound and then localize its direction, but that's the main function. The ear canal, on the other hand, the only skin-lined hole in your body, just think of your face alone. You've got 3 other holes that have mucous membrane, but this is your face extending inside your head. It's just skin-lined. So it's more prone to bacterial and fungal infection and to have bugs move in and dirt go on your eardrum and a whole bunch of things. So the body secretes this amber oil called cerumen. We know it as earwax. And unlike what you might think, a brown substance coming out of a hole, which seems very much like waste material, is actually a functional material that has antibacterial and antifungal properties, will keep your ear healthy and uninfected. It also provides an odor that keeps bugs from moving in. It collects dust and dirt to keep off your eardrum, so it goes from amber oil to dark brown because it's doing its job. So you're supposed to have some earwax. The second thing interesting about ear canals is that they're a tube and they have a resonant frequency. That means that there's going to be amplitude or volume at a certain bandwidth because of that resonance. And typically in ear canals, that peak is around 3,000 or 4,000 cycles. So you can see a 6 dB increase from that resonance or up to 26 dB in amplitude, depending on the ear shape and size. And the reason I'm mentioning this is that when you lose hearing from loud sound, regardless of whether it's music or noise or whatever the case, hearing is always affected in that octave band. In fact, people in the military, people working a punch press in a factory, and a guitar player or a violinist all have the same pattern of hearing loss that centers around those frequencies that are amplified with ear canal resonance. So we can identify your hearing loss as most likely being caused by loud sound by just looking at it. Sound levels then hit your eardrum, and Mr. Shure decided to figure it out a long time ago, looking at that eardrum, that when you put sound waves hitting a diaphragm, they can convert it to vibrations and then do something with that signal. And so much like a mic diaphragm, the eardrum is doing that, taking sound waves, converting them to vibrations. And then we're in the middle ear now with 3 bones that connect the eardrum to the inner ear so that the vibrations can pass through. We'll not spend much time on the middle ear because none of those areas get damaged by loud sound. There's a lot of things you read. I always get a little bit frustrated in the literature when somebody says he's going to blow his eardrums out, or I'm blowing my ear, I ruptured my eardrum from loud music. I think eardrums can take up to, we think about 180 dB before they actually blow out. So your music will never, ever, ever hurt your eardrum or rupture it.
I don't think a human could create a sound that loud.
It is an explosion coming off next to somebody's head. These are military studies. So that's not the issue. The issue is the nerve cells inside of that inner ear. And if you can see the inner ear, there is this shell that if you were to unroll that, there's all these nerve fibers in there that go from 20 hertz to 20,000 hertz in order. And when they get stimulated, they respond and send signals to your brain. That's where the damage occurs. And in fact, what the discovery was is that when things get too loud and you injure yourself, free radicals form as a result of oxidation that occurs at the cellular level. And in fact, there is a group right now, I'm involved with another research study that starts next month, of an antioxidant vitamin formula that might, in lab animals, actually cut the risk by 50% of losing hearing from loud sound. So we're going to start running human trials on front-of-house engineers in the music industry starting in April to see double-blind studies to see if it works on humans. So stay tuned for that.
Interesting.
Wow.
So hearing loss is when those nerve cells die, and once they're dead,
they're dead.
They're dead.
And that's the thing. There's no bringing them back. Cochlear implants, I've heard somebody say, I'm just going to get a cochlear implant. Cochlear implant, here's how music sounds on a cochlear implant. That's what it sounds like.
Oh.
There's no tone to a cochlear implant. Not what you want to have. And plus they drill something in the side of your head and you have a wire coming out of your head with something built into your head. It's really not a good choice. Stem cells, not there yet. So nothing replaces the original parts. The best thing is to preserve what you have. So what causes hearing loss? There's a lot of misconception that age is a cause of hearing loss. But the main cause is genetics. You can inherit it. Disease. People get ear disease, even musicians, even though somehow they think they don't. You can get injured through ototoxic, which is medications that are toxic oto to the ear, is what oto means. So certain medications people take to save their lives can also cause injury to your ear. And you could also get hit in the head or punch a hole in your eardrum. Those first three, genetics, disease, injury, those are rare. They do happen, but not at the frequency of the next two, which is poor vascular function and loud sound exposure. My opinion is those are the leading causes of hearing loss in this country. Loud sound's an easy one. You guys get that, or else you wouldn't be tuned in today. But the vascular function is misunderstood. The ear needs blood supply, and it needs a good supply of blood. And so if you do things that are vascular restrictive, like smoking tobacco, we know that tobacco smokers have double the risk of losing hearing as a non-tobacco smoker because it's a restrictor of blood flying through your veins, right? So also if you had diabetes or any other vascular disease or heart disease, high blood pressure, high cholesterol, anything that clogs up your pipes is going to reduce your hearing.
But just not getting old.
Not age.
Nope.
So what's the most effective part? The most important part of hearing conservation is the hearing test. The most effective part of hearing conservation success is the motivation and educational part of it. And in fact, when we see somebody for a first patient visit, it's an hour visit, and over 40 minutes of it spent on educating and motivating, and only 20 minutes on taking a hearing test and an ear impression. That's the important things are there. Just to get an ear impression and a test does nothing for you unless you know why and all the aspects of why you're doing this and what are some of the risk factors that you have, so you can make educated choices. And of course we try to motivate the hell out of you to get this thing done. Excuse the words, but we get you going.
Why would you pay the money to go if you weren't going to do something about it?
That's right.
I suppose there's a certain aspect of motivation just by the fact that you made the appointment to show up. So once you've got him in the chair, then you
That's
can...
right.
Yeah.
But in research, everything shows that this is the most effective thing. And when you go to National Hearing Conservation Association, which are all the experts, there is a consensus with every researcher that the most effective way to get people to protect their hearing is through motivation and education, not through a product. So what happens when you're on long time exposure of loud sounds? Well, the injury occurs, and the effects from the injury can include a number, if not all of these things, but one is, we call it hearing loss, but it's also known as a temporary and or permanent loss of frequency resolution. It sounds much scarier when you put it that way than just loss of hearing.
And it should sound scary.
And it should be scary. The second one we have is tinnitus. Other people call it tinnitus, but itis in medicine is itis. This is itus, and itis in medicine is a Latin ending that means infection and inflammation. Tinnitus is a term that means you have noise in your head. It's not a disease, it's a descriptor. It's like runny nose. You don't have runny nose disease. You have a cold. You have a sinus infection. You have an allergy. Well, just like tinnitus, there's many other causes besides loud sound exposure. So people could have problems with their jaw or neck, mechanical issues. They could be ingesting something like caffeine, which causes tinnitus. Tinnitus is not bad. It's just 60 million people in this country have tinnitus. That's 1/3 of the population of this country say that they hear tinnitus on a regular basis. So it's not uncommon, all right? If you're only hearing it every time you perform, then you know you're doing something bad. If you don't hear it after you perform, doesn't mean that you're not doing something bad, because about 70% of people who lose hearing from loud sound never get ringing. So you can't use that as the measuring stick. Hypersensitivity just means that loud sounds sound way too loud, and because you have so much hearing damage, you can't hear the soft ones. So the very small range between what's comfortably audible and what's uncomfortable is about 10 dB. These end careers. You have to turn it up to X amount of dB before you can enjoy it, and then 10 dB louder than that, it's hurting your hearing. So the tinnitus and hypersensitivity, distortions in your ears, or diploacusis, which is an inability to find pitch, these things end careers. End careers.
Devastating to a singer if you can't find your pitch.
How about it?
Terrifying.
So we talk about sound levels. There are two scales. These are criteria scales that are judging what safe exposure levels and time. Remember, it's all related to time and loudness. So when I talk about sound exposure, think about it like you think of sun exposure. Three factors involved in sun exposure and noise exposure. One is susceptibility. Right? Some people can go outside with real pinky skin and in 10 minutes they're burned at 95 degrees, and you get other people with darker skin that can go out there for half an hour and they don't get burned. And so hearing loss has those same aspects. Some ears are more sensitive to damage and injury than others. But we can't look at you to tell which. So actually we treat everybody as if you are the guy with the pink skin. We treat you as if you're the most sensitive. And that's what these scales are based on. But OSHA, Occupational Safety and Health Administration scale, was started back in the 1970s, and we thought that was a pretty good scale. At 90 dB, you could do an 8-hour workday for 40 hours a week and still maintain your hearing. And so you can see every time you go up 5 dB louder, at 95 dB, you can only be in it for 4 hours. At 100 dB, just 2 hours, 105 an hour. And so after about 30 years of collecting longitudinal data on all these factory workers who've been following OSHA regulations to the T, we found that 22% of them still lost hearing. So we realized it wasn't covering the most sensitive ears. It was covering 80% of the ears, but 20% still weren't in there. The international standard, ISO, as well as the National Institute of Occupational Safety and Health, NIOSH, have recommended the 3 dB exchange rule and the low fence, instead of being 90, being 85. So if you look at the time you get to 100 dB, OSHA is saying that you're okay for 2 hours, and NIOSH is saying you're okay for 15 minutes. Big, huge difference in exposure times.
Especially to musicians.
Especially to musicians. Now, the equal energy rule on the bottom there, this NIOSH formula, protects 96% of ears. By the way, 4% still lose some hearing. So nothing's totally predictive. What does that tell you? Number one, that's why you should be getting your hearing checked every year, because then you can decide, even if you're following the scale, is it working for me or not? The other thing I want to mention to you is that it's difficult to follow as a musician that 3 dB rule. And so that doesn't mean you should throw your hands up in the air and say, well, I can't be protected, because if you follow the OSHA rule, and I'm giving you 100 dB for a 2-hour show, that's pretty good. By the way, these are all A-weighted. But if you can comply with that, that means you have close to an 80% chance. And remember, too, that these two scales were built on noise standards. We're not sure if music and noise have the same effect. We do know that music causes hearing loss. There's no question. Some people question that, but we don't know if it does have the same effect. So we're using the noise standard, and so you still might even have a better chance than the noise standard of protecting yourself using OSHA. All I'm saying is OSHA is better than no scale, because you're giving yourself an 80% chance.
Now, you mentioned earlier that the hearing loss, the frequencies where it happens, is the same no matter what caused the loss, right? If I understood that correctly?
No, I was trying to tell you that regardless of the sound content and frequency curve of the stimulus causing the hearing loss, hearing goes down in the same octave band.
Right.
So if it's a low frequency rumbling from some machine, or it's a gunfire from the military, or it's a punch press, or it's a violin, they all are different frequency content and spectrum, and yet hearing gets damaged in the same octave band between 3,000 and 6,000 hertz because of the ear canal
frequency
resonance.
Content that's coming at you doesn't matter.
Doesn't
sufficient
dictate
level.
where the hearing's going. You'd think that low frequency hearing would cause low frequency loss, but it doesn't. It always causes loss in the same octave based on that ear canal resonance. This is the cornerstone of every hearing conservation program. I've talked about it again and again, but here we are. Initial audiogram to get a baseline, and then to recheck it once in a while, because if you're going to do hearing loss prevention in the music industry, it's a compromise to what you're used to. If it's ear monitors, you're turning them down probably then less than you used to listen. If it's earplugs, they don't sound quite the same as it did without earplugs. So look, it's a compromise, and if you're going to do that to protect yourself, you might as well do a test and retest to see if it's actually working. Otherwise, it's really crazy not to even bother. So what are the methods of protection? Of course, you know, there's traditional earplugs. I've seen muffs. I've seen napkins, rolled up cigarette butts, a famous thing in the blues scene here in the drummers and blues scenes. There's high-fidelity earplugs in a custom and generic form. Of course, you can turn in-ear monitors down so they can have the potential to be used as a hearing protector. We'll talk about that later. And of course, as I mentioned before, you can acoustically modify your work environment in some cases.
I think the high-fidelity earplugs in particular are worth maybe reiterating to people who aren't aware of them or what they do, because a lot of people instantly react negatively to earplugs because they're thinking of the drugstore little foam bullets that you stick in your ear canal and kind of muffle everything. But these are different.
These are different. They are meant to mimic the open ear response and allow you to, well, on the top left is a generic one. So when you talk about can't afford anything, these things sell for under $20. Most places you can get them for $10 or $15, and it's a fairly flat 20 dB response. That might be too much for some people, but at least it's a protector available for anybody that can afford that. On the right-hand side is the custom earplug. We call them ER. Actually, it's from Etymotic Research. These are all their products. They have patents on them. Those are 3 different filters. There's a 9 dB, 15, and 25 dB cut that are interchangeable. And in the center is an electronic earplug that is used to actually get louder when things get quieter and get quieter when things get louder to help you with that sort of thing, because they work very well with symphony orchestra players and somebody where the dynamic range changes, but it never really gets too loud. These may not be able to tolerate very loud sounds without breaking up when you get into a rock band, but for symphony or choral group, that could be a good protector to use.
So those must have a little battery in them.
They have a little battery, like a hearing aid. Mm-hmm.
Interesting.
But every earplug's a compromise, even the best ones. Not much of a compromise, but it's still a compromise. But here's why personal in-ear monitors are so popular. Unlike the earplugs, they actually enhance the sound quality. People are buying earplugs because they're worried about their hearing. People are buying ear monitors because they can hear themselves better on stage. They aren't buying them necessarily to protect their hearing. And so that's something to think about. It's making them so popular. And of course, everybody claims that if you use properly, won't hurt your hearing.
That's what they all say, right?
And you ask them, how do you do that? And they say, don't turn them too loud. Boy, thank God, I would never have thought of that one. So there are ways that you can actually tell. We'll talk about that in a minute. But they do come in different materials. And so, and they also come in different sizes and shapes. This one's showing you the 3 types, really. There's a generic, that's a Shure product, with actually a silicone custom sleeve that Sensaphonics builds for the Shure product. In the center is the common acrylic earpieces, and then on the right are silicone earpieces at Sensaphonics, where you only use the silicone. There's really not really many silicones, as surely in the pro audio there's no silicone companies. They all like the acrylics, but we believe ear canals change, and the better the isolation, the better chance that you're not going to turn things up. If they're a leaky ear monitor, then you're going to end up turning up. Can we make plastic as tight as silicone? No, we can't. Let's go to the next slide and we'll talk about that. Oh, we're going to speakers. I'm sorry. So that's all right. These are what goes in these things, right? This is your typical Apple earbud, and it's called dynamic, and it's round, and it's got venting on both sides. If you look at the white side of it, there's 6 vents there. That's to let that diaphragm move, and it's also designed to work in an open ear canal, which is about 2.5 millimeter cubic centimeters. And so what are you going to do for this thing? If you're going to put a mold on it or anything like that, it's going to change the response. The amount of isolation of this bud without anything around it is about 2 dB. So,
which is, for all practical purposes, not really isolating.
That's correct. Yeah. So the next speaker is called a balanced armature. Typically, that's what's in, I think, all but one of the Shure pieces. They're new electrostatic now, but everything else is BA, and all of our products are too. And in fact, most of the custom in-ear monitor companies in the game, I would say, are doing things in balanced armature world. Why? Well, because they sound better when they're not vented. So you're able to plug your ear up and get better sound quality rather than worse. And in fact, when you take the seal away from these things, they roll off the base. So if you get a balanced armature earpiece with no bass, it's probably because you're not fitted correctly. Of course, it can be used as a single or in multiple combinations. How many are too many? Well, I don't know.
That's a debate. We actually have another webinar on that topic in our archive. If you look up the earphone technology webinar, there's quite a bit of discussion in there about the multi-drivers and at what point does it become diminishing returns there. But yes, there are some advantages.
There are some advantages. So now we're back to materials, and as I was getting into this earlier, the balanced armature speakers actually sound better with a tight seal and no leaks, especially on the bass end. Okay, in fact, if you loosen it completely, you'll lose all the bass. What are those variables for a good seal? Well, one is what material you're using. If you're using a hard material, then it's not going to be able to seal as well. And the reasons for that is, number one, your ear canal moves from side to side. It is not a static piece. So when you get an impression of your teeth for something, they're static and they take this exact impression. They don't move, your gums don't move, but an ear canal is very moving. It moves all over the place, especially when you sing or play a wind instrument or open your jaw in any way. So you'll never see an ear monitor with a generic tip that's plastic or hard. They're always soft. The Shure ones have a rubber tip, a foam tip. Everybody has soft. You never find an over-the-counter earplug that's made in hard material. That's because the earplugs move. So based on that, we believe at Sensaphonics, and I think Shure does too, that the softer materials will isolate more. The other thing is how you take an ear impression by putting a bite block in, which you'll see people do all the time, based on one single study, and that study showed that 60% of people got a better, tighter fit using a bite block. 60% is not a mandate. That means 40% didn't. It also didn't show you that 22% actually the ears get smaller when you do that. And there was a 28% that one ear got bigger and one got smaller. So if you're doing it that way, chances are you're not going to always get the best seal. So go to an audiologist who knows what they're doing and not stick a bite block in every time. Isolation, though, creates new problems, right? People can say, gee, I look out in the audience now that I got these great isolating ear molds on, and all I see is mouths open, and I can't hear any sound, or when we're trying to talk to each other between songs, we can't even get the words that we're saying, what? So that's a problem for people, and there's also a loss of localization and directional cues, something that you don't really think about with in-ears in, but when you had them out, your drummer was behind you, and maybe your guitar player to your left, and when you turned around, they'd switch around a little bit. But now, wherever you go on stage, you have that mobility with being wireless, but the sound isn't changing with you any which way, so you lose your localization and directional cues, and you're also losing your spatial recognition. And what do I mean by that? Your vision tells you you're in a big room or a small room, but so does your hearing. So if I were to blindfold you in a closed closet, then walk you into a gymnasium, you would know you went from a small to a big space. And so here you've got your ear monitors in, and your brain's telling you you're in a closed closet, and yet you're looking out into that gymnasium and wondering this something isn't right. So what do people do? They take out one earpiece. How often have you seen this?
Too often. Too often.
Well, here's the downsides to that for hearing. Number one, there's two ears. When they put together, they actually summate to give you a 6 decibel increase in loudness perception. So if I give you a 90 dB signal in both ears, your brain tells you it's 96 dB. Pull one of those ears out, and now that one ear's got to be turned up 6 dB louder, twice as intense, or if you use the Naya scale, cutting your time in half twice in order to be able to hear it as loud. Then you have an open ear now with nothing in it that's getting bashed by the drummer and the amps on stage and the PA and the crowd and whatever else. And then because you hear with your brain, the loud volume coming in through your open ear will start affecting your ability to hear in your closed ear, and you'll end up turning it. We call it central masking, and the way to exemplify central masking is to have you get on a cell phone in a loud, crowded place, and you can't hear, and when you put your hand over your open ear, you can hear them better. And so that's a really easy demonstration as to what happens. You could wish you could turn that phone up louder, but you can't. The second thing that people do is put a hole in it, which is not the best either, because now you've lost, if you're on a balanced armature piece, you've lost your bass response. If you're not in a balanced armature, now you've opened up your ear to all the stage volumes, so you're going to crank those earpieces up over the stage volume. And not only that, that vent is going to be probably 1 or 2 millimeters, and your ear canal is about 10 millimeters. So you can imagine, if you know nothing about physics of sound, that there could be probably a different sound quality on those two different size diameters. So we say that these two options should be avoided in all cases. Leave them both in and do not punch a hole in it. What do you do? Well, the most popular and commonly used thing is people mic the room. They strategically place microphones around to hear the things in the room that you want to hear, and you can control how much you want to hear. If you find that's not enough because you're still missing localization and spatial cues, there's an ear monitor that Sensaphonics makes that has actually mics built into it so that the localization is there and they move with you wherever you go. Those are the preferred ways to go.
And you can control the level of those microphones.
Of those mics, that's
so
correct. And turn them down. You can't turn them up, by the way, from Unity Game, but you can turn them down in 4 dB steps, yeah.
Cool. So are they safe to use? That's the thing that we hear all the time. You know, people just maybe even they make the assumption, right? I'm using it in your monitors. It's safe. But as we say, yes, if used properly, which is in quotes for a very specific reason.
Right.
What does that mean?
Right. Well, and as you can see in our little cartoon here, it's I'll just tell the patient to turn it down, because when you call these ear monitor companies up and say, we're the only company, I'm the only audiologist owning an ear, and so we're probably the only company that's focusing on hearing loss prevention as our main focus rather than how many products we can sell at the door. But if you call up anybody making ear monitors and say, how do I use these safely, they'll tell you, don't turn them too high. Turn down the volume. Thank you so much, because nobody would ever thought of that. So the scary part is this. We ran a study at Vanderbilt with Jeremy Fetterman, a musician who suddenly became an audiologist student. He wanted to get a PhD in audiology, and so he wanted to see the difference for his capstone project between how loud people listen to ear monitors compared to floor monitors, because he always hears that ear monitors are the safer device. So I got involved in the study, and I'll tell you what we did. We had 15 musicians. They each had 6 trials that we measured sound levels. 3 of the trials were open ear from a wedge, and 3 of the trials were in-ear. And how did I measure is that I have a probe tube, a very thread-like tube that I go right to the eardrum, and I can connect it to a microphone outside of the ear. So I'm taking my measurements at your eardrum. Doesn't matter where the speaker's placed, whether it's in your ear or across the room. I'm on the other side of it all. So now I can measure levels at the drum, and we told them, turn up the floor wedges to what you like. And they did, and we'd measure. And then we said, we're going to do that on 2 different days, 3 different days. So we took an average of 3. And then we're putting an ear monitor in with that same probe tube, and we told them to turn. This was a Shure E5 with a Sensaphonics silicone sleeve that really isolated. And we told them to turn those to what they like, and we were going to compare these 2 averages, 6 trials a person. And the amazing part, which wasn't all that fun to look at for me as a manufacturer, is that everybody in the study turned all 6 trials exactly the same loudness. Not one of the 15 people turned it up 1 dB higher or lower on any day, whether it was wedge day, whether it was on the floor of the ear. By the time it got to your brain, it was the same level with a correlation coefficient of 0.8. That means there's a 98% chance that this is what every musician does.
I liked it this loud when they were speakers on the floor, so I'm going to turn it up to the same loudness.
That's what your brain is telling, but it's music, right? It's rote. You've been practicing your guitar at 110 your whole life. You're not going to put on in ears and suddenly go, I only need 100 now. No, you don't. You need what you're used to.
I say, it sounds like a bunch of guitar players.
Well, it's everybody. Let's not blame the guitar players. So the second part of the study, we said to them, okay, turn these things down, your floor wedge down till you can't hear it anymore, and we can only go down 1.8 dB. At 2 dB, most of them are like, that's too much down, I can't hear. We asked them to turn their ear monitors down, and everybody's going down 6 dB, 10 dB, and they're saying, oh yeah, I can play here, it sounds pretty good. So look, it's a behavioral change. It's not the product. So are ear monitor safety devices? No. If you get an isolating one, can it be used as one? Yes, if somebody shows you where you should be. So how do you know? And that's the problem. There's no speedometers for ear monitors. There is one. We make it. It's called dB Check. And what you do is scroll through there. You choose the device because it's based on the device's frequency curve and sensitivity. We have all of the Sensaphonics product on there, and the only other company on there is Shure. They agreed to go on. So any Shure earphone or any Sensaphonics earphone, I don't think we have your new electrostatic on there yet, but everything up to that we have on there. So if you needed to find out how loud you were listening to, this reads drive voltage, knowing the sensitivity, and then it gives you an A-weighted SPL measurement. This one's saying 92 dBA, and then it tells you how many minutes on those two scales. The NIOSH scale, the equal energy one on the left, which says 96 minutes, and the one on the right, the OSHA scale, that says you have 364 minutes. And it doesn't make you do anything. It's just giving you the speedometer to say, do you want to turn it down or not? But it's information for you, and until you have this thing in line, you really have no idea whether or not you're too loud or not.
It's really important for people to understand that you can't just correlate the position of the volume knob on your in-ear pack, wireless pack, to know how loud you're listening. There's
because the variables are the sensitivity of the earphones, which could be a difference of maybe 20 dB even. It's how loud you have the transmitter turned up. It's how loud the things are cranked on the soundboard. So it really doesn't go by just volume control.
Yep.
And there it is again.
There. Great. And so how loud is too loud? Again, just to kind of reiterate, we showed you the OSHA versus NIOSH sort of exposure times earlier, but this is the OSHA exposure times here, but it kind of gives, for people who may not be familiar with the scale, sort of a reference for, approximately how loud some of these things are, noting that, 100 dB is basically the threshold of pain, where you're listening and going, I actually physically am feeling discomfort from the level here. And some of these might be overestimating it a little bit. Rock concert at 115 dB, that'd be a pretty loud rock concert, but they get there.
Oh, yeah.
So, but that could just give you some ideas here. But then the second part of this, which is, interesting to see then to what Michael just mentioned, was that, earphones are all different. So here we've got 3 different earphones with different sensitivities. And so when you look down the leftmost column here, you can see these are different power levels in milliwatts being supplied by the amplifier, in-ear pack, whatever is driving the earphones. And then, so for a 1 milliwatt input, here we've got 3 very different values. And note that, if you're using earphone number 2 at a milliwatt, 105 dB, that's like a voice shouting, nearby. You can listen to that for an hour. But with earphone number 3, 122 dB, that's above the threshold of pain with the same amount of power being applied to it. So it really is important to see how all earphones are different. And as we noted earlier, the more drivers, the more efficient they tend to be, which means they're going to be louder for a given signal level. So you have to consider that as well.
My comment is the damage or safety and damage. Having done this for a long time, safety is a bad word because rock and roll and safety just really don't mix too well. So rather than call it, not to criticize, rather than say damage or safety, I say injury or quality of life, because damage is your car, but you get injured, right? Don't take it so impersonally. You're injuring yourself, which is crazy. Mm-hmm. So here we are again, injury or quality of life. Well, quality of life and good hearing requires, proper education, which Shure has been generous enough to give time to do this today. Some real-time measurements of how loud you're hearing things, and then a regular hearing screening to make sure that if you've taken the time and effort to do something, that it's actually working.
So just going once doesn't help a whole lot.
That doesn't do much.
Just establishes a baseline.
That's correct.
Yeah.
Got to go back.
Great. Okay, so before we head over to questions, I'll just mention that this webinar will be archived, as they always are, at shure.com/training if you have anyone else that would like to hear it. To get notification for future webinars, you can go to shure.com/subscribe. If you have any other questions that we don't get to today, you can always email us. You should go to the Sensaphonics website, sensaphonics.com, and you can get lots of good information there as well. Cheryl, we got any questions?
We have some questions. We'll get to as many of these as we can in the next 10 minutes. First question. I play trombone in a high-energy dance band and stand next to the drummer. Any suggestions on what type of hearing protection I can use that won't sound plugged up? I need to be able to hear myself, besides just through the bones in my head?
You're a wind instrument player, and unfortunately for you, yes, we have, well, first off, the easiest and most effective thing to protect your hearing is always an earplug, because ear monitors, you run the risk of turning them too high. So if you're looking for that, yes, there are earplugs. If you haven't tried one of these musician earplugs, 9 dB cut is maybe not enough for you, but it may be, but even it's still better than zero that you're using now. The problem with earplugs is that you have a head resonance that you hear more if you play a wind instrument or you sing. If you're a drummer or a bass player not doing vocals or a guitar player, those earplugs sound fantastic. When you introduce voice or noise within your own head resonance and you're trying to judge the timbre of your trombone, it takes time for you to adjust to those plugs. So I would get the plugs and then I would try practicing at home till you can do it. It is done. We have tons of trombone players and trumpet players and wind instrument players and singers that have gotten used to it, but it does take some time.
Great. Okay. Does the Sensaphonics Hearing Clinic accept insurance, like a specialist visit fee? No, they do not. Okay. Quick, easy answer there. Does high blood pressure and the medications to treat it have an effect on hearing loss? How about the use of baby aspirin or Advil? This person has tinnitus and sometimes they feel they're losing their hearing.
Okay. Hearing and tinnitus are different things. What may cause your tinnitus may have nothing to do with your hearing, and we have tons of people with bad hearing and no tinnitus and tons of people with horrible tinnitus and perfect hearing. So keep those in mind. I'm sorry.
High blood pressure and the medications?
The high blood pressure could, if it's just hypertension, that can cause vascular problems. It isn't caused by vascular problems. Hypertension is its own disease. That's high blood pressure. And it causes your heart to overwork, and then you can have some vascular problems because of that. So, yes, that would be part of possibly a vascular beginning of a vascular disease, and that could be the medications for blood pressure, not that I'm aware of now.
Okay.
Aspirin, baby aspirin, 1 a day, no. That's low aspirin, but if you were to take 2,000 milligrams rather than 82, then yes. So there are some things that are toxic to your ears, and as far as tinnitus goes, caffeine and aspirin are 2 over-the-counter things can make your tinnitus much worse.
Okay, great. Next person says, I don't always carry an SPL meter. Oh, how come on? Why not? Don't we all? Is there a smartphone?
I've got an app from.
That's the question. Is there a smartphone application that you feel is most accurate in measuring SPL?
Well, there is smartphone apps, but they're not going to measure. I think I know what you're going to say, at your ear canal. So it depends.
Well, it's not just that. Some of them are pretty accurate, though. I mean, as far as general, right? I mean, it's better than nothing. And do I have one I recommend more than others? I really don't. But it really depends on so many variables. The shape of the microphone in your smartphone is one thing, and the app is developed. They don't have one, oh, this app is for smartphone A or smartphone B. It's a general app. So there's going to be some differences in your ability of your mic and your phone to be exact along with the app, but it's better than nothing.
Yeah. The one I have allows you to calibrate it actually to, if you have a known source, then you can use that source to calibrate it, which is still better, but you know.
And which one is that?
It's made by Studio 6 Digital.
There you are. So you have an answer.
So.
There you go. All right. Do noise-canceling headphones actually protect hearing, or do they just give the impression of less amplitude or noise?
Active noise canceling.
Yeah.
Active noise canceling is ANR. We call it noise reduction. And they're throwing a signal that's 180 degrees out of phase with the incoming noise. And so, unfortunately, for the noise canceling technology, it is only really able to take care of the lower long width frequencies, like, you know, up to maybe about 1,000 hertz. Sounds that occur over 1,000 hertz are too fast for them to cancel in time. So it's great at protecting hearing if your exposures are, if you're relying strictly on the noise reduction technology. If the exposures are below 1,000 or 750 hertz, you're probably going to do very well in protecting yourself. If the exposures are the high frequencies, it's not going to do much at all unless there is some kind of an acoustic cup on an earphone that might also reduce some highs. But yeah, it can help to reduce. It's just not for music, because think about it. It's getting rid of bass. and not highs. And basically in music, most of the musicians I work with would like to keep the bass and get rid of some of the highs. So it's really not used on stages very much that I've ever seen.
Okay. Why do we use A weighting instead of C weighting? Doesn't A weighting ignore low frequencies, which cause just as much damage?
That is, well, first off, they don't cause just as much damage, but that's not the question. You are exactly right, whoever you asking this, because A weighting is kind of unfair. What we did was, remember, we started these things a long time ago, so A weighting was matching what's called the Fletcher-Munson curve. Fletcher-Munson had a curve that shows the softest levels that ears can hear certain sounds. You don't hear them all the same, so it takes about 45 dB SPL to hear 125 hertz, and at 1,000 hertz it's about 7 dB. So you have this curve that really de-weights the low frequencies. But as things get louder, to say your point, why are we not measuring in C, you're right. Because as things get louder, that curve, that Fletcher-Munson curve, we call it equal loudness contours, when you get to about 90 dB, it flattens out. And who's listening below 90 on a stage? Nobody. So why didn't we just use the C? And we could have, but we didn't. And so what we have is 45 years of research in the A scale that was incorrect from the beginning, but nobody really wants to go back and recalculate everything again. So we already know what A does. So we're using the A scale. But lows don't damage as much, by the way, as highs, because it takes so much more sound pressure for the low to be heard, even at the higher volume. So.
All right, this guy says he's going to see The Who tonight, and he forgot his earplugs. Are tissues effective?
I just at the Who show last week. It's not that loud.
Oh, there you go.
I put in my earplugs probably a third of the show. There's a couple of songs that really got up there, but and I was sitting right near the front of house PA.
How times have changed. See what he just said. I went to the Who show.
And it wasn't that loud.
Well, it wasn't killing me, right?
You heard it from an audiologist.
Well, remember, I think Pete Townsend has had his problems. He's gone public with it, so I don't know if they're all into it either anymore. But anything you put in your ear is going to reduce sound level. So yeah, it's going to sound horrible, but
that's why you need your musician's earplugs.
Yeah.
Right.
As we mentioned earlier, even the custom ones that are, they're less than $20, right?
I mean the
non-custom.
The non-custom ones, right?
Yeah, you can probably find those. They're called ER20s. You might be able to find them at a drugstore or somewhere that sells them.
Music store,
stores, Guitar Center or something, yeah.
So, but bring something.
Bring something. In general, how does excessive earwax affect hearing loss?
Well, it doesn't unless, until it doesn't. It does until you take it out. Earwax is just a temporary. It builds up, and so you take it out. There's really, your problem with earwax should just be if you're having trouble with buildup all the time. The best way is to see a doctor, but if you can't do that, you can buy drops and a little syringe at the store, and that's the most effective way of getting rid of it. Do not stick anything smaller than your elbow down there.
All right, let's see. Lots more questions here, but I'm just going to pick one more. So if I don't get to your question, many apologies, and please feel free to send it to us to support@shure.com. Let's see. There's so many.
She's looking for a good one.
Okay, here's a good one. Most musicians at my church who have purchased custom molded in-ear monitors. Most of the musicians at their church have purchased custom in-ear monitors, molded in-ear monitors. All the IEM companies that seem to have monitors available produce in plastic as opposed to silicone. Is there a reason most big-name IEM companies don't produce in silicone?
Yes. You can't print silicone, and you can't pour silicone like you can acrylic. To make silicone is really an artisan skill. Our lab techs, I have two that have been with me for 16 years. You have to be an artisan because you actually have to form the entire thing. It's a single piece in silicone. You have to drill it out, put the components in, seal it back up. This takes years of practice and skill. With the acrylics, it's like making a jewelry mold. You can just take an impression, put it into a piece of silicone, pull it out, and you pour your plastic in there and cure it with a UV light, or you can even print them now off of a scan, the 3D scan. So it makes it easier and easier to make them. And it's also, when you go to repair them, you can crack that plastic open, replace the speaker, and put it back together. When the silicone breaks, you have to throw it out and put in a new one. So cost and ease of use and all that are the reasons people do acrylic.
Great. All right. Well, we want to thank you so much for joining us, and I'm sorry if we didn't get to your question, and hopefully we will see you next time.